Okay, I think we are live. So I'll just confirm that things are going. Okay, I think we are live. Okay, cool. So, mhm. So I have been delaying this for quite some time, and the idea is to learn Rust in public while live streaming. And there are many things that I wanted to try, but I haven't been doing this. So I thought that it would be a better idea to actually stream while learning to showcase my learning journey as well as uh, keep myself accountable that I'm trying to learn this programming language. So, yeah, I have been learning in parts from time to time, but it has never been consistent. And that is one of the key things that you should note. Whenever you're trying to learn something, you need to be consistent with that. So if you're trying to learn, let's say Rust here, so you need to like learn it for 15 minutes every day. That is better than doing it for 1 hour in 10 days, every 10 days. So uh, cargo run. So I've set up this project and it's pretty easy to set up a project. You just need this command cargo init dot if you're inside a folder, or you can just type in cargo init and the project name. So it will just initialize the project. You can go inside there and type like cargo build to build the project. And there are different commands that you can have with cargo. I think so. Cargo testers for like running the tests, which I'll cover shortly. But yeah, this is the very basic program that we get when initializing a new project in Rust. So it's a simple hello world. I'll just check back. Okay, the stream is, so it's a simple hello world. Okay, so things are going well for now. I'll also just uh, okay, cool. So, um, so this is from my previous chat where I was trying to develop Kafka. That stream will be continued, but I'll continue it some other day. So I'll be trying to run 2 to 3 different streams at the same time. So one is developing Kafka, which I will do after some days. So there was a very basic program that we wrote last time, but I won't discuss about it now. So we can get started with learning Rust, and there are many ways to go about this, but this I can leave it here for now. Okay, so there are many ways to learn Rust. So one is this Rust programming book, which is quite famous, and it's recommended that we start with this book, and we should complete this book because it explains things like from the very beginning, and this is pretty cool. uh, I think we can pick a chapter from this book, or I can just like do some random things today and maybe I can cover, yeah, I can just cover maybe random things, and at a later point of time I can also follow the book. So first of all, let me explain what is the USP of Rust? Uh, Clearly, when you're trying out this programming language, it is not as simple as writing a hello world in. I mean, the hello world is obviously as simple as anything else, but there are different things that you should keep in mind while writing a Rust program. So by default, the values here are owned. So um, you cannot just copy, you cannot just pass the values thinking that it will work the same way as it does in other programming languages. So my primary programming language is Golang, but yeah, Rust is quite different from that. So ideally, when we pass a value to a function, that value is copied over to that function. But in case of Rust, we need to define explicitly what we want to pass that value as, whether we want to pass it as a mutable borrow or we want to just copy that value. And I think copy is very cheap for primitive data types like Boolean, int, etc. U16 or U32, whatever we have here. So I won't go over those basic data structures like if else and those kinds of things, let's um, but I'll explain obviously some of the details. So first of all, let's just try to write a function. Function. Uh, so there is this function called add, uh, which takes in a base. Let's like keep it as int 16. I don't think int 16 is the type. It's I16. So it takes in the base I16. So I'll keep on repeating things and I'll keep adding things on the go. So people know that whenever they are starting with a new REST program, they can, um, like, they have to follow some of the things which we are going to do. So first of all, you can see that uh, we have these problems. So this code is not in use, and it's giving us a warning that this code is not in use. So we can add to disable this warning. So first of all, there are a bunch of macros that we should use. I think the syntax is this: allow unused functions, unused variables. I think, yeah, if we use this exclamation mark, it enables it for the whole file. So if you remember that if I don't use this thing, you can see that base is also complaining that this is a number is being uh, that is being used. So you can just click on this quick fix, and so there are a bunch of suggestions here. Either we can use underscore for a number that is not in use, or we can just use this macro, allow unused variables. So I'm doing that for now. Similarly for add int, it's complaining that we are using dead code. So we should also allow that. So these are the two things that we are allowing for now, just to silence of the warnings, just to remove those warnings. So add integer. So it takes a base and it takes, let's say, an offset. Now, uh, there are certain things here. So first of all, if we are adding, like if we have a function which simply adds an integer to a base, we can either return a new number. So we can return the result, which is of type I16. And if you have not implemented this function, you can just add a to do that to be implemented. I think uh, I think to do should work. Yeah. Yeah, so to do works. So it's just a macro. Again, what is a macro? So that is something we will discuss later. but you can just use this macro to do and with this exclamation mark that this is to be implemented, or you can just like give any random message that you want. So let's try to call this function here, add integer 2 and 3, and let result is equal to this, and we can simply print the result. I think we can also print it like this. And let's try to run this program. So we can see this error that thread main panicked and not yet implemented, and this is the error message that we had to be implemented. So I hope the screen size and everything is okay. Okay. I hope that the screen size is good enough, or I can just increase the font. Okay, I think the screen, like the font size is good enough. Okay, so now I will just explain what we have done here. So first of all, we had this function which is yet to be implemented. We added a macro that this is to be implemented, and this is the same error that we also got when we tried to run this program. So it panicked. Uh, it, so you can see that it panicked that the function is not yet implemented, and this is our message to be implemented. And just to be clear, if I just give any random gibberish message, it should just print that message, which is fine. So yeah, implement me. Okay, so this is a function that we had, and clearly it was complaining initially that this like there was a warning that we have dead code here. So I just use these macros on top that allow dead code and allow unused variable, so we can just pass in the variables as we want, so we don't see that warning. Now this is the function add integer, which will take a base integer and some offset, and it will just return the result after adding it. Okay, so let's implement this function, base plus offset. This is a very basic implementation. Like this is a very basic function which just adds this offset to the base and gives us the uh, result. Okay, and now again, there are 2 to 3 things that I want to show here. So we can either do this, let result is equal to base plus offset, and then return the result. This is perfectly fine, but our compiler will tell us that you can simply remove return and remove that colon mark and then that semicolon mark, and then if you just type here result, it will return the result. But then again, it is complaining that even this is not the best way to do it. You can simply just have this expression base plus offset, and since like you can have like multiple expressions, since like these are empty line of code and this doesn't affect anything, but this won't affect anything, and the final expression without this symbol will be the return statement. So if we are doing base plus offset, it will just return base and base plus offset. uh, yeah, and we get the result. Now what is happening here is that in the main function we are capturing the result of 2 plus 3, and then we are printing the result. Now running this program, we get the answer as 5, which was expected, and yeah, this works fine. But now there are some things. So this is a very basic example, but now I want to show some things here. Let's say that so this is a very primitive data type, which is I16 and 16, but we don't want that. What we want is so when we are passing that base here, it is just copying that number. Let x is equal to 2, and we are just passing x here. we can also explicitly define the type here. So x is I16 and we are passing x here. Now the thing is that if we try to print x, so this works. Why this works? Because we are explicitly, uh, because since x is a primitive data type, it is being copied here. But this is not the example that I was going for. So let's just make a uh, struct number which has a base of I16, and let's try to define this as number which is equal to let's make it as 2. So now instead of a primitive data type which is I16, we have defined a struct which is our number struct, and now x is a number. So we need to change the function accordingly. This takes in a number. I'll call it as num. So it is number plus number dot base plus offset. Okay. Now let's see what happens. So now we have the same function add integer, which takes in the type number, which already has this base field and some offset. Now it adds the offset to the number and then returns the number itself. Uh, so clearly we went this way because I wanted to show something, and that is now when we are trying to print the number x. So first of all, we can't print it because we need to have this derive debug implemented. So I will just, what is the, I forgot the, okay, I'll just do this. Okay, so it is hashtag derive debug. Okay. So now it should be printing. Okay, now, okay, so this is what I wanted to say. First of all, let's just remove all of this. So we defined a number. We defined a variable x, which is of type number, and number is our struct, which like encapsulates this base inside of it. And the first problem that we had was we couldn't even print it. So for that we use this macro. Whenever you define a struct, there are some things that you can define here. I think clone copy also you can define, but I'll, and if I do that, now you will see that the error is gone. So we will just like tackle that step by step. I'll just remove this clone and copy for now. So I'm just defining this like uh, I have defined this macro on top of it, derive debug, which will tell us that we can print this using the println macro, obviously. But initially it was not there, and uh, we couldn't like even print that. So that is one more thing that I wanted to show. Now coming back to the implementation, when we are using this function add integer, I'll also just keep some new lines here so that it's easier to explain. So we have defined this number x, and then we are calling this function add integer. Now add integer takes in the type number. So you can see that we are passing this variable x to add integer function, and what happens is that add integer now owns this variable. So if you do this in any other programming language, I think like C++ or Golang, I think what is done here, what is done there is that they copy it by default. But in Rust, it is move by default. So you know you need to explicitly tell what we are doing here. But for now, we are passing in the integer x to this function add integer. and that is what is happening. So now when you try to print x, you will see this error that borrow of moved value x. So this x value goes out of scope here. So let that sink in. When we are calling this function add integer, we are actually moving the value x inside this function. So now this function owns this value and it is out of scope, and you cannot simply just print that value because that value is gone. Uh, Now if I try to do cargo run, you will get this very beautiful error message that value borrowed here after move. So we have already moved the value. Move occurs x has type number, which does not implement the copy trait. So if you want to copy that value, which was being done for the i16 data type, which is a primitive data type, you will have to have this copy trait implemented for this struct. But since we don't have that copy trait, and I'll just do this copy. So now you can see that, okay, I think clone, okay, I'm not sure that, I think you have to have both the traits together. So now it has copy and clone trait both, and so even I don't know the differences between those two. I'll have to look it up. But you can see that if we are using the clone and copy trait for this struct, now we are able to print the struct because now that is copied here. So that is copied and we are not moving that value simply. Um, so coming back to the error message, I'll just remove this for now. So coming back to the error message, it is the compiler is telling us that this takes the ownership. This function takes the ownership of that variable. So that variable is now owned by the function. You cannot simply, so main cannot simply call that function again, call that variable again, use that variable again, because that variable has already been passed or moved to this function add integer, and it is now out of scope. So that's what's happening here. Now how do we fix this? So Rust tells us that if you want to borrow a number or borrow a variable, you can simply do that. For that we will have to implement it like this. So now num is of type and number. So we are borrowing this, uh, we are borrowing the number data type. So what you need to do is simply just use this AND operator, and now what's happening is that this function is now borrowing this value, this variable x, and after that we can still use the value x here because it was just being temporarily borrowed by this function add integer. Yeah, so that is one thing, and now this is fine, and you can just do multiple prints or whatever because uh, yeah, so the rule is, so the first rule of Rust is that you can borrow a value multiple times, but uh, you cannot like mutably borrow it, but you can just simply like borrow it like read wise multiple times, and that is still a valid thing in Rust. uh, okay, so initially when we implemented this, we moved the value and that value went out of scope. We couldn't simply print it in the current scope, in the current main scope. And now we are using this AND operator, which tells us that, hey, we are borrowing this value from the scope and we will return it after we are done. So it borrowed it, it used it, and the value was returned to the scope, which we can print again. Now there is a third thing, which is like mutably borrowing a value. So for that, we can have like AND mutable number. So what this does, so what is happening here is that now we are mutably borrowing the value. So we are borrowing, so just think of it like this, that we have a value which is in one scope, and then we have two options. We can either move that value from one scope to the other, like we can let the function handle that value now. So we are moving that value from main to the add integer function. That is the first option. The second option is that you can borrow the value only for like read purposes and then return it back to the scope. And the third option is you can mutably borrow the value So you can do operations on top of that value. So add integer. Now instead of doing this, what we can do is we can use this so like we won't even return a data type now. Okay, we are not returning anything, we are just calling this function add integer. And now add integer is modifying the value in place. So you can see that we are adding offset to the base, and then we are also assigning it to base itself. We are modifying the value in place. So that's what's happening here. And uh, now this is complaining that you cannot simply pass and x because add integer function expects a mutable borrow. So now clicking on quick fix here and adding the reference, we can simply call and mute x. But the problem here is that x is not mutable at all. So in Rust, you need to also define that this is a mutable variable x. So x now can be mutated. Earlier, it was immutable. So by default, any variable you define in Rust is immutable by default. You need to explicitly tell Rust that this variable is mutable and it can be mutated in the future. So now we are defining it as let mute x. So x is a mutable variable, and then we are passing the mutable reference to add integer function, and then it is applying that it is adding the offset to base and then modifying the base itself. Now if we print this, we will see that the base is now 5, which is 2 plus 3. So if I do cargo run here, we can see that it is number and base is 5. So it modified the value in place. And uh, yeah, so once mutable you can see that once mutable reference is done, this function does its execution, and the scope of this function ends here. I'll just draw this. So the scope of this function ends here, and this is what lifetime is. uh, Lifetime starts, lifetime add integer starts, and lifetime add integer ends. So basically the lifetime starts here and the lifetime ends here uh, for this function. And inside that we are mutably borrowing this value x. We are mutably borrowing this value x, this variable x, and then this function goes out of scope, and the mutable borrow of x is returned back to the original scope, which is the main here. So once we have returned back the mutable borrow, we can now simply print x here. So that is also fine. We are able to do that. So like there are a ton of concept even when you like do the simple function implementation, but once you get used to this, you'll be pretty comfortable that okay, this is fine. uh, okay, now coming to the Rust programming book, I think we can try understanding something else. So let's try to understand this box type. There is one more thing that I would like to explain here. Uh, so this is I16, which is very uh, so this is very limiting. First of all, we cannot only call this function for I16 data type. But what I want is that I want to call this function for any data type t uh, for which addition operation can be performed. So how do we do that? So we can simply add like a generic here, add integer t, which takes in mutable number. Now we will also have to make this as a generic implementation, and I'll define the data type as I16. So now x is of type number I16, because initially we had like hard coded the data type as I16, but now we are making it generic, so it can be even U16 or something, whatever we want. So that is one thing. And now add integer t types an offset of type t as well as number of type t. uh, I'll just add a to do here, or I can. So now coming to the function definition here. Initially we had the type as I16, and that I16 was a fixed and hard-coded data type, and the function was not useful to us at all. Now it takes in any type t, which is of type like mutable number t, and then an offset which is of type t again, and we can now add both this. Like we can simply add these types. So it will be number dot base plus equals offset. Now again, there is a problem that this type t should implement the add assign trait. So now this generic type t should follow some constraint. So yeah, so this generic type t is fine, but it should be constrained. We cannot have any type t. The type t should assign, like should implement this trait add assign, and that will make our problems go away. uh, so it is standard ops add assign. Now this function works and we don't have to think about anything else. We know for sure that this function implementation is complete in itself. So this function implementation is complete in itself, and it is very beautifully written here. So the type t should implement the trait add assign. Now what are traits? That is again something we will discuss in some time now. Yeah, so just to give a basic idea, trait is like, uh, let's say we have a trait called adder, which implements function add. Again, so there are many things that need to be discussed for trait, but for now you can just think of it like if you're from Golang background or TypeScript, you can think of it as interface. So traits are simply interfaces or contracts that must be implemented by some struct, uh, so that like instead of just using that struct everywhere, we can create functions that takes in the parameters which implement a particular trait. So yeah, so like I'll explain trait in detail later on, but for now, just to see, just to show the composability here. So add integer is a function. Now I'll just remove integer, I'll call it as add. So add is a function which works for any type t, as long as that type t is implementing add assign. As long as that type t is implementing add assign. And what does this add function takes? It takes a type of number t as well as some offset which is of type t, and it simply adds the offset. So just to have this plus equal to implemented for any type t, we need to have this trait implemented. So this is the composability thing that I was talking about. This add is a generic function in itself which takes in a type t, and it works as long as the type t itself implements the add assign operator. Yeah, so I'll also remove this. This is not needed for now. Lifetime is another topic that we will discuss in detail at a later point of time. It like maybe I'll prepare something to show the use case of lifetime. Okay, now coming back to the function here. Now add integer. Okay. First of all, it's add only. So now this function works. It takes in of type number u16, which and an offset which is of type u16 again. So we can explicitly define it as 3u16. So 3 is of type u16, and println will still work. So this concept is still valid like it was before. Now, instead of this, if I were to give I16 here, so this won't work. Why? Because now we have enforced a constraint on this function add. The constraint is that whatever type we are giving to add, it should be same as the type which is for our struct number. So number is actually like number t, so it is number u16. That type should match with another type that we are giving here. Now if this was not there, then how will we implement this? Then we will have to define a type again t. With t we can define a type u. So now this definition will work. We can pass in any other type here, but now we cannot simply add num of base to offset. And why can't we do that? Because those are two different types, first of all. So what we can do here is, again, uh, I think there is this from, I think into, I don't know if this will work. So basically what I want to say here is that u can be converted into type t. Mm, the trade bound is not satisfied. Okay, I think this is dot offset dot into, so this will work. So it does. Okay, so first of all, again, we don't need to think about anything else. We can just focus on this function. If I were to tell you about this function now, it takes two types, t and u, where u can be converted into type t, and that can be done by calling dot into. So if we just look at the straight into, it implements only one function here, which is the into function. So whatever we are passing here, whatever type we are passing here, it should be able to call dot into, and it should be able, like it should be able to convert into type t. Now it's complaining here that I16 cannot be converted to U16, but I think opposite can be done. So if it was 3 U16, and let's say that this was I16, I don't think, okay, if, okay, okay, so this is crazy. Now, if I were to just write some comments here, so clearly, like if you think about it logically, U8 can be converted into I16 because the number of bits are always higher. So like I16 has 16 bits, but U8 is an 8-bit integer. So that can be converted into a higher bit, but we cannot do this. We cannot do this. Why? Because first of all, U8 is 2 to the power 8, which is I think 256. So this will go from 0 to 255, and I8 I think goes from minus 127 to 127 or 128, whatever. So clearly this is not possible because we will have this overflow thing here. Obviously, like this is not correct and even possible, but U16 is, I think, again, I can be wrong with these exact numbers, but it is something like similar only. So now U8 covers this range. So this works for U8. So U8 can be converted to I16, but obviously I16 cannot be converted to U8 because so any I cannot be converted to U because integers can be negative, but unsigned cannot be negative. So that conversion is anyway not possible. But if we want to convert a U with any number of bits to I of any number of bits, we cannot simply do that. We need to go to a higher bit order. So clearly, like you can see that this works. So if we pass in 3U8, it can be converted into I16. and I think this should work. So as long as it compiles, um, there's a high chance that it will work. So you can see that we have number with base 5. So there are a lot of things that we covered here. Even like implementing this simple function helped us understand that uh, like there are many things at play here. You have power to define each and every type. So this is a pretty generic function that takes in a type t as well as type u. We defined this number just to show you that if we don't implement the copy and clone trait, we cannot simply pass in the value and then use it again in the same scope, because the value is moved by default in Rust. So we need to mutably borrow the value or borrow the value depending on what we want to do with it. And this was a pretty cool implementation where we call dot into. So dot into automatically converts the type u into type t, and yeah, and this is the function, and it's like pretty weird looking, but it works. And this is what Rust is all about. uh, okay, i think I think we are somewhat late here, so I'll come with another day of learning Rust, so day 2, where we will discuss about box pointer, this box data type, and how it works, um, and why like we cannot do recursive things here. So I'll just give a brief here. So the idea is that first of all, these are very primitive data types and they are defined on the stack itself. But if we want to define something on the heap, we need to have a pointer or access to that. So box is simply like defining some data type on heap. So when we do this, let x is equal to 4, uh, or I can say let y equals 4. Uh, so this y is actually defined on stack. This is assigned on stack because it's a fixed value. So the length is fixed. It is I32. We already know the length of this value, so it's defined on stack. But if I were to do it as box new 4, now this box I32, this is defined on heap. This value is defined on heap. This is not on stack. So when we use this, we are like using the value from the heap itself. We are not using like these primitive data types that are defined on stack. And yeah, so that is one thing. And now the thing is that like even if we want to define some recursive data types like a tree node or a linked list or whatever, we need to use this box data type. Why? Because recursive data types, in case of recursive data types, we cannot uh, uh, yeah, so we don't know like how long that data type extends to. For example, in case of a list, we know that it is a combination of a node. It is a combination, like in case of a linked list, it is a combination of a number as well as a pointer to another list, and we don't know that what is the length of that list. So that is not defined. Therefore, we cannot just define it on stack. We must define it not we must define it on heap, because now box is actually a pointer. You can think of it as a pointer which is of fixed size. So now this will compile and we can like define these recursive data types here. uh, so we'll just read this article later on in the next video, but for now I think this is enough because we are already late. So I'll see you in the next one, and thanks for joining. We will be running 2 to 3 series in parallel. One is like learning Rust in public, the other is like diving deep into distributed systems. So I'll see you in the next one, and thank you.